Am I on? Yes, I'm on. Excellent. So I'm going to talk to you about frame rate conversion in a file-based world. So traditionally, why would you need to frame rate convert something? So obviously, historically, life was very simple a few years ago. We had something called PAL and something called NTSC. And if you were doing international deliveries, you had to go and either make a PAL tape or an NTSC tape. Life was beautiful back then. Then unfortunately this thing called HD came along and ruined everything by suddenly having all these other frame rates. So you started having to deliver an HD cam tape or an HD cam SR tape, but you had to deliver potentially in lots of different formats or different frame rates. So you might have to deliver in 2398, 24, 25, 50i, 60i, progressive, PSF. You had to upconvert stuff from PAL to 50i or 60i. You had to take 60i material and maybe go back to 24p or 2398. Things started to get more complicated. So you needed a device which could actually do all this at high quality, do the frame rate conversion and upconverting. So that's where these lovely hardware-based boxes came along. So historically, hardware-based solutions offer the kind of highest quality standards conversion and frame rate conversion. And typically, the one everyone's very familiar with is the Snell Alchemist product, which does sort of very high quality frame rate conversion. So the key thing about Alchemist, it has some very particular algorithms to do with motion estimation and compensation. So what the algorithm allows the system to do is to kind of track the motion and velocity of a pixel within a frame, and then it can actually sort of synthesize new frames or basically take frames away. And it uses some sort of other sort of quite sophisticated algorithms to do this sort of very smooth motion. So the good thing was it happened in real time. So you had to get kind of baseband video in and out of an Alchemist. It is only baseband. So the challenge there was you needed, you still need, a playback device to actually play your source file or tape. So you first need a tape deck or some sort of disk server playing back the file to baseband. And then coming out of the converted file, or converted baseband video, you also needed another device, such as a tape deck or a disk recorder. So lots of equipment required to actually sort of perform the frame rate conversion. And plus you first had to kind of get a file or a source tape into the kind of baseband domain to actually kind of play it into an Alchemist. And also it was kind of difficult to upgrade. I mean, if a new algorithm came along which was superior, very difficult to kind of respin chips and reprogram FPGAs. And it couldn't actually go fast in real time. The benefit is it can go in real time. The disadvantage is it can't go any faster in real time. It is a real-time process. So that's kind of a typical kind of hardware-based sort of highest quality frame rate conversion. Then along came non-linear editing systems, various software transcoding type products. Which again, a lot of them offer frame rate conversion. I mean, things like Media Composer does frame rate conversion, Final Cut Pro offers some, so does Premiere Pro and various other editing systems. But they typically use what we term an optical flow algorithm, which again is a type of motion estimation and compensation, but it doesn't have quite the sophistication which something like an Alchemist algorithm produces. So the quality typically around the world is not accepted by broadcasters. If you're having to deliver a program and it needs to be frame rate converted for international distribution, it does require to go through a product which can actually do proper motion estimation and compensation. So typically, the one everyone typically uses is an Alchemist. But there is a better way, I'm glad to say. There is technology now where you can do automated high quality standards conversion. But instead of using hardware in terms of proper kind of hardware cards with algorithms running on FPGAs, you can now use an NVIDIA GPU. So typically for quite a long time now, people in the gaming industry have used graphics cards to process 3D effects or 3D kind of motion to do sort of gaming with. And some of that technology is now being used actually in the video domain to do with pushing around video pixels. So the latest kind of algorithms out there actually now enable you to run the frame rate conversion process through an NVIDIA graphics card instead of using actual kind of dedicated hardware. But you get sort of basically similar results to an Alchemist, or in some ways you even exceed an Alchemist in sort of quality. So, I mean, a lot of these, this particular algorithm uses not just motion compensation and estimation, it uses other kind of proprietary algorithms to do very, very smooth motion. One of the beauties is obviously being file-based, that you can sort of automate large transcoding of deliverables. So if you've got an awful lot of international programming to get through, you don't have to have someone sitting there playing tape recorders back and forth and playing around with disk servers. You can just load up all of this in a queue, in a file domain, and run them through the GPU. So the nice thing about running through a GPU and using a computer rather than a hardware solution is it can run faster than real time. So depending on kind of the speed of the computer you're running it on, these graphics cards now can run sort of much faster than real time in terms of the kind of processing. So you aren't gated by a kind of real time process. So I'm not going to list every item of this huge feature list here, but I mean, this algorithm it can sort of scale from SD to HD to kind of 4K and kind of beyond. So it has very sophisticated tools for doing things like automatic kind of 3-2 pull down and reverse telecine. It can do kind of cadence detection and fixing. So for example, if you've got a scene where you've shot some television screens playing back within a picture, and they're all running at different cadences, they're all running at different frame rates, the algorithm can basically choose, you can tell it to choose an overall frame rate and it will fix all the different cadences in the picture. So it's very sophisticated, the sort of technology it's using in terms of its sort of motion estimation algorithms. And it can also sort of handle kind of different pull-down patterns so you can preserve a kind of film look. So for example, you can go from sort of very smooth motion to go from 2398 or 24p progressive material to a 50i interlaced output, for example, in 1920 by 1080. So it will still be an interlaced frame, but it will still retain the kind of film look, the film sort of progressive look and feel. So it uses a very sophisticated algorithm. So I was going to give you a very quick kind of show of some cadence sort of correction and a few different frame rate corrections. So if I click on here, no. Oh, here we go. So here it's kind of running through, it's doing sort of up conversion. So on the left we've got kind of a typical kind of transcoding product, and on the right the algorithm's called Tachyon, hence why it's called Tachyon standards transcode. But these are just basically showing kind of different frame rates. And a lot of algorithms which don't use proper motion estimation, they tend to kind of have to try and retain the duration of a piece of material. They tend to start blending the kind of frames and motion. So you start to get quite a lot of blurring within, and the cut points you get kind of a lot of blurring. So you'll see on the kind of the left things look a little bit blurred. On the right, through the algorithm, they can look much more defined. So especially kind of objects with sort of very defined sort of edges, a lot more kind of smoother and kind of clearer than with a standard frame rate converter. So these are just some sort of examples of kind of going up, going down on various conversions. So if you actually want to see this, we've got a system downstairs running this technology. So if you want to kind of have a look, I can kind of take you through it later. So this should be the very last conversion here, I hope. With the circle. Excellent. Right. So the great news is we talked about in the previous session our ContentAgent file-based management product. And this is now this technology we've built in as an option into ContentAgent. So the option, we actually sort of supply you with a specific graphics card, a specific NVIDIA graphics card, which does this kind of processing. So the beauty of having it kind of within this is, again, it's giving you kind of the file-based speed rather than having to kind of go back through baseband video. And the kind of key thing is you can kind of, within our kind of workflow tool within ContentAgent, it doesn't just do sort of a transcoding from one format to another format and then doing the frame rate conversion. You can obviously add on other processes, so it can do things like you can add in a file-based quality control process after it's done this sort of transcode and frame rate conversion, and then it can automate the whole kind of delivery process. So whether it's FTP or rendering out to a UNC path or using an Aspira kind of WAN acceleration product, so you can build a complete kind of file-based frame rate conversion delivery system, which is obviously difficult to do when you're having to kind of go back to baseband in and out of something like an Alchemist. And that is the end of my little presentation.